Dear God, we thank you for today. We thank you for those of us that are here and those of us that are going to join us eventually. We'd like to ask you that as we go into this math lesson, we may be able to understand everything Chair is going to teach. We ask you for the confidence to ask questions for those who may not understand, Lord, and for understanding for the whole class. We'd like to ask you, God, to bless our Chair, Mr. Nguyen, that he may be able to teach and use language that we understand and use examples that we understand, and that this lesson may go well. In Jesus' name I've prayed. Amen.
Thank you, Helen. We have Mr. Bakayana in. John, you'll help me monitor the messages, and yeah, you can chime in case there is something to communicate to the girls. Last week, I told you that I'm going to wind up. John? John?
Yes, please.
I don't know if it's you seem to be having some sound from your end.
Maybe I can mute.
Yeah, you mute for now. You'll try to admit those who will be coming in later, and maybe monitor the chat, as well as muting those who are making noise for us. Girls, the rules are still clear. If you have a question, you can put up your hand. I'll be able to see you, or Mr. Bakayana will see you. And then you can ask. If you're not talking, kindly keep your microphone mute so that there is some kind of order. So I encouraged every one of us to go and check the document which I shared some time back. By now, I expect some people to have gone through that document, and if there are questions that you feel I should able to attend to before I wind up this topic, please, you can ask them before I start on the cumulative distribution function. Do you have any questions? Okay, if there are no questions, then I'll straight away go to the cumulative. I told you to complete the examples that required you to use properties of variance. The assumption is that you've done that. So today we are going to look at cumulative distribution. Now, I want you to reflect on how you get cumulative frequencies in a discrete, descriptive statistics. We did that in at the start of S5. Can someone remind us how we get cumulative frequency? Someone to remind us, how do we get cumulative frequency?
We keep adding the frequency we have to the one above it.
So you keep summing up frequencies until you exhaust all the frequencies. Now we are going to use that same knowledge. When they ask you to find the cumulative distribution function, they basically want you to keep adding the probabilities until you get the value corresponding to the last variable. Okay, so the last variable is supposed to give a value of 1 because we expect probability to add up to 1. Okay, so we shall be adding the probabilities with their respective discrete variables. Okay, sometimes they give you the descriptive distribution function. They can state it as a formula, or they can just give you a table. So whichever way they state it, we should be in a position to work it out. And the formula which we use to work out that descriptive function is the probability of x less or equal. So when they say less or equal, depending on how many values are below that given variable. Okay, you can always add up the probabilities up to that value. Okay, so we shall look at that shortly. I want us to straight away go to that example you're seeing. Example number 1, they have given you a PDF and they are asking you to construct a cumulative distribution table. So if I may pick that and I take it to the whiteboard. I don't know if you're seeing my whiteboard. Is everyone seeing my whiteboard? No.
Yes.
Yes.
Okay. So that's these are the values which are in that table. Is corresponding to that, 4 is corresponding to that, then 5 is corresponding to that. Okay, so they are saying we generate a distribution, a cumulative distribution table. Let me put that information in a table so that it's easier for us to. So usually what we do, for the start, I can create a row for the probabilities, but it's optional as long as you can read them off the question. So we have 1, of 2, of 3, then 4, 5. So our X values are running from 1 1, 2, 3, 4, then 5. And the corresponding probabilities this one is 0.5, 0.25. By the way, these probabilities add up to 1. Have you checked? That is the first test you need to do before you can move on. Okay. So now on this part, you can either put a capital F. Okay. Or this one, if you want, you can use this. The probability that X is less or equal to small x. They mean the same thing. Okay, but most people put a capital F. Now, just like in descriptive statistics, usually the first value of frequency is what begins. Okay, so to go to the next value, I'll get 0.05 plus 0.25. What do we get there?
0.3.
0.3 plus 0.3.
0.6.
0.6.
0.6 plus 0.15.
0.75.
0.75.
Then 0.75 plus 0.25.
1.
So usually the last value of the cumulative distribution function is supposed to be equal to 1. The value which corresponds to the last variable. Okay, it's always supposed to be equal to 1. So basically the question is asking you to just generate this lower part. Okay, that is what that question was asking you. So in an examination, I will not expect you to state the probability part, okay? Because it's already given in the question. Instead, you use what is given in the question to come up with what you see me circling here in blue, okay? So basically that is what cumulative functions are all about. I don't know if we are having any question there before I look at one with a function. Do you have any questions? Yes or no? Okay. In case someone has a question, ask. Yes, Immaculate, you have a question?
No.
Okay, can we look at number 2 briefly before we look at number 3? Number 2, they have already given you the cumulative distribution function. Eh? So they want you to use it to work out the parts below. One thing you need to note is for you to do part E, okay, the expectation part, you cannot do it without knowing the individual probabilities. So much as we can add and we go to 1, we need to as well know how to work backwards. Just like if they give you a cumulative frequency, they can ask you to generate frequencies. So even here, they can give you the cumulative distribution function. They can give you the probabilities, and then they'll ask you to generate the individual probabilities that relate to what they have given you. Okay, so I want us to briefly go through that. So these are my variables, and they want me to use these variables to work out. Can someone tell me? The questions? What was Pat asking you to do? The document now.
To find the probability of x is equal to 2.
Equal to 2. Does anyone have an idea what this question is asking us to do?
Yes.
So what do we do? Using what they have given us. Remember, they have given you cumulative. So what do we do?
First find the
We subtract.
Immaculate, you want to share with us?
0.54 minus.
Okay.
To find the probability of x is equal to 2, we subtract 0.13 from 0.54.
You subtract 0.13 from 0. Why? Why do we subtract?
Because they've given us a cumulative. They've given us a cumulative frequency.
Yes. The cumulative.
But if we are to find the but if we are to find the probability,
yes,
we define, let's say the probability at 1 is 0.13, but to find the probability at 2, it means the probability at 2 was added to 0.13 to get 0.54. Okay. So to find the probability, you subtract what's before.
Okay, thank you. Adija, did you have a different view, or do you want to supplement on what Immaculate has just told us? Adija?
It's kind of the same, but it's kind of the same. But for my view, I feel like we should construct a probability distribution table, a PDF, I think. And like, because we are going to use the value, we need the values for the other numbers as well. So if we could just do it at once, it would be easier.
So your view is that we first generate the individual probabilities since we shall use it to get expectation. Okay, assuming they didn't put part E, okay, because sometimes they state these questions and they don't ask you to find expectation, or they basically want to use you to use this information to calculate different probabilities. Okay, so since we are used to getting the other probabilities using the other approach, let us as well learn how to use the cumulative function. So when they tell you to find at 2, okay, the function at 2 has the probability of 1, okay? So for you to get the probability that corresponds to 2, you have to take away the probability of the function at 1. So in other words, to get at 2, we shall get function at 2 minus function at 1. Now, function at 2 is 0.54 minus 0.13. So this takes us to what Imagine was telling us. You get the value of the function at 2, you subtract that. So what does this give us?
0.41.
0.41. Okay, so that becomes the probability. You could attain this by generating a table as Adija was telling us. Yeah, but I want us to learn as well how to use this. Okay, maybe I can put that on the side here since we shall use it somewhere. So this is 1, 2, 3, 4. Okay, so you have x at 1, at 2, at 3, and then at 4. Here I need the probabilities. This is 0.13. This one we've just seen, you subtract and you get that. So what value do we get at 3? What is 0.75 minus 0.54? Yes? Can I?
0.21.
Yeah, you shouldn't. This is supposed to be an interactive class. Don't just look on as I'm typing. Okay, so this is an alternative. Okay, so you can see that we could have worked out this other number by just reading off directly. Okay, as Hadija was telling us, you just read off directly from the table and you'd get that. But I want us to run the other way also. Okay, so can you look at part B? What is part B telling us to do?
To find the probability of x greater than 1.
X greater than? So x greater than 1. What exactly do they want us to do? Any idea?
Okay.
Yes.
So to find probability, you can get 1 minus the probability of x less than 1.
You can get 1. Why? Why are you getting that? Why are you getting that? Okay, can I hear from Gift?
It's because
I thought the probability of x greater than 1 is equals to the probability of x is equal to 2 plus the probability of x is equal to 3 plus the probability of x is equal to 4.
Yes, that is true. That's an alternative. Yeah. I know we can use this other table to work out that. Yeah, but I'm encouraging us to learn how to use the alternative because this one we know. Okay, this one we know, we've done it before. So I'm basically asking us to run the other way. What if the question doesn't want us to. Okay, I know people can always fast sketch this, but at times to waste time. If you can run out to do it using the information given in the question, that is also okay. So when they talk of greater than 1, remember that the function usually talks about less than, okay? So it's very hard for you to use the information given in the table directly without first converting it to some kind of less than a given value, because it's cumulative. Okay, so since they are telling us to find the probability for which x is greater than 1, it implies we are looking at 2 onwards up 4. But you know that the whole, when you sum up all the probabilities, they add up to 1. So when we get the whole, which is 1, and we take away what is less than, what is below 1 and below, because 1 is not inclusive here. So it implies that we can, the other of writing it, you can see it's 1 minus the function at 1. Okay. So when you get the whole minus the function at 1, then you should be able to get the value of those other probabilities. Okay. And at 1, we had that, which gives us what? 0.8 what?
0.87.
Okay, so that can be the first approach. The next approach can be using this reading off directly from the table that you've just generated. You sum up the probabilities, okay, which gives you 0. I think gives you 0.87. Can you add and you tell me if you're getting the same answer? You get the same answer?
Yes.
Yeah, so these are 2 options you can use, but you can see that this is more direct. Okay, it's easier if once you've understood how to use the cumulative distribution function. Okay, you can always go there directly. But those who can't do it directly, you have an option of using the table you've just generated. Okay, great. What was the other part asking us to do?
Probability of x greater than or equal to 3.
Probability that x is greater than
of x greater than or equal to 3.
X greater than or equal to 3. So what exactly are they asking us to do here? When they talk of greater or equal to 3, an idea?
Yes, you can find that probability by getting 1 minus probability of x less than 3.
X less than 3. Afia, do you have another view? Gift, Afia?
No, maybe we can also use this one of adding the probabilities of 3 and probability of 4.
Okay, you wanted to give us the alternative. Okay, let's first look at what we have in the table. So if they tell you to find the probability of which x is greater than greater or less than 3, it's as good as saying this, less than 3, okay? Because 3 is inclusive, But what is less than 3? Less than 3, we are looking at 1 minus the function at 2. Okay? Because when I say the function at 2, it includes all the values which are below 3. So what was our value at 2? Our value at 2 was 0.5. Okay? And that gives us 0. What?
46.
So you can use that first approach, or if you had to use the alternative, Yes? Sorry? Okay. If I'm choosing alternative, you can say that for the probabilities for values which are greater or equal to 3, 3 is inclusive. So it would be the value of 3 as the value at 4. What? 0.1 plus 0.25. And this yields, I guess, the same answer. Okay. So we have two ways of attempting this work, and the choice is yours. Okay. Then what is the next question asking us to do? Part D.
Probability of x less than
Probability
X
less than
what?
2.
What exactly do they want us to get here? Less than 2 means what?
Probability
F of 1.
It is the
f
same,
of 1
the same as that.
less than or equal to 1.
Yes, which is the same as the function at 1. And the function, we see that we don't have other values there. Was it 0.13?
Yes.
Yes.
Okay, great. So that is what they want you to do. Then finally, they are saying find the expectation. Okay. So as Hadija told us, we have that table which we generated, and expectation, if you still remember, it is the product of x times its corresponding probability. I'll not write the formula. We've used it many times. Instead, I'll straight away go to the substitution. What was with 2? Can you read
0.41.
0.41?
0.41.
3? 3 had what?
0.21.
0.21.
0.21.
Then this was, I think, 0.25. Okay, can someone multiply and you sum up? What do you get? If you want your messages to be attended to quickly, you should send it on the general chat. If you send directly to me, at times I'm concentrated on the whiteboard. I don't read them that quickly. That's why I told you Mr. Bakayana will be alerting me. So Amanya is asking us to repeat part C. Can someone help us explain part C to Amanya? Let me go back. Part C is there. Yes, someone to help Amanya do part C. Okay, Gift. Yes, Gift.
So part C, they were asking for the probability of x is greater or equal to 3. So that is the same as part C, they were asking probability of x is greater or equal to 3. So that's the same as saying 1, which is the total 1 minus probability of x less than 3, because 3 is inclusive, since they are saying x greater or equal to 3, so 3 is inclusive. So the function, the probability function at which we have as x less than 3 is the function of 2, which is 0.54. So we are getting 1 minus 0.54. Or if that method is not okay, you can use this normal method of probability of x greater or equal to 3, which is equal to probability of x is equal to 3 plus probability of x is equal to 4. There you use the probabilities. Yeah, that's how I understood it.
Okay. Thank you. So it seems the settings don't allow to send on the general chat. I guess we did it as was done as of preventing people from being distracted. But you can always send those messages to Mr. Bakayana. He will alert me. Okay. Thank you. But I'm seeing, okay. So I don't know if that makes sense to seeing 2 hands up. Can I hear from Rina? Rina? Rina, your network.
Is the probability.
Yes?
It is function of.
I don't know if Mr. Bakayana is getting your question. I am not getting the question. Your network is static, eh?
Teacher Theory.
Yes, John.
I think let her write. I'll pick it from the chat.
Okay.
Then somebody is asking about the. Let her write. I'll pick it from the chat.
Okay.
Someone is asking about the second table, that she didn't get the second table. I've asked her which table she's talking about.
This one, which is having boundaries of red, it is what we generated. Eh? We got it from this. In the question, they gave us this one. Eh? So we used this first table to get the second table. Second table, we realized it had values which will enable us to do part E. Okay, that's why it's important the question 40 before you start doing the number, because you get a plan of how to do it. Eh? So with the second table, you can easily work out the questions, with ease. Only that I was giving them this other approach just in case they don't want to use the second table. So the second table, we basically subtract. We keep subtracting as we generate the values, just like how we do it for cumulative frequencies. If they ask you to find the individual frequencies, you keep subtracting backwards. Eh?
Though someone is saying that she thought that the probability function of 2 was 0.41.
The probability of 0.41. Yeah, that's true. You can see that in the table, the probability of 2 is here, 0.1, and we calculated it using this other method here. It's the same. Okay, and to get that, you basically get 0.54 minus 0.13. So it takes you to the same answer. Okay. Okay. Can I move on? Someone tell us what we get as our value for expectation. What is our expectation?
2.58.
2.58.
Okay, so this would be our expectation.
0.5.
Okay, that would be our expectation. I don't know if we're having any questions, because I want to now look at a question which is a function. Eh? What we've been new values in a table. But as I told you at the start, sometimes they can express it as a function.
Theodore.
Yes, John.
There's a question here that I've been trying to understand what she's trying to ask.
Yeah.
Because she's saying that in the table given in the question, we have probability function, but we are asked in them as probabilities. I don't know what she's trying to mean.
Okay, the values which we are seeing in the table, they are probability values we generate using that function. Eh? So sometimes they will not tell you that it's, they might not give you a function per se, but they will give you the values you get as a result of substituting the variables in the function. Eh? So in other words, they substituted 1 in that function to get 0.13. Then they substituted 2 to get 0.54. So it's implied. Eh? It's implied. They might not state it as a function, but they will give you the values you generate using that function when you substitute the variables. Eh? Maybe let's look at the next example. She'll pick it. So what was the next question asking you to do? They gave you a discrete random variable X, and you are given a cumulative distribution function as X squared out of 9, and is valid for 1, 2, 3. Okay. Now, our function is varied within this range. Eh? 1, 8. So the question they're asking is find the function at 2 and then find the probability of X equal to 2. Now, how do you get a function at 2? When they say find the function at 2, it's as good as substituting in. Okay. So function at 2 is going to be 2 squared out of 9, which is what? Which is 4 out of
9.
Now, when they say find the probability, what exactly do they want us to do? Yes? Any idea? Someone to guide us. What exactly do they want us to do when they say find the probability at X equal to 2? We've just looked at that in the previous example. You saw that if they have given you a function and they are saying you find the value at a given variable, it's basically getting the function of that variable minus the function for the previous variable, which is fx at 1. Okay. So at 2, we are having 4 out of 9, and when you substitute 1, of course, 1 is 1 out of 9. Eh? Okay, which is 3 out of 9, and this is a third. Eh? So it's basically that. There is no rocket science here. You just need to use the same knowledge, just like what we did in the table when we had values in the table. Okay.
Teacher, where is the 9 from again?
Where is the 9 from?
Yes.
Yes.
Teacher.
Yes.
Where is the 9 from again?
Are you saying the 9 which is which we are subtracting 1 out of 9? Is that what you're saying?
Yes.
The 9 is given in the function. Have you looked at the function? Our function is here. It has a 9 down. Eh? So I've substituted 2 by putting where there is x at 2, which gives me 4, because 2 squared is 4. So I'll get 4 out of 9. When I substitute a 1, I'll have 1 squared. 1 squared is 1. Eh? So it will be 1 out of 9. Does it help?
Yes, teacher.
And because they have a common denominator, I basically subtract the numerator, which is 4 minus 1, and gives you 3. The out of 3, you can reduce it to a third. Okay? Can someone read me
Yes,
what are they asking us to do?
Write the probability distribution of X.
Okay, thank you. So when they ask you to write the distribution of X, it's easier if you generate yes? Someone is trying to ask a question? I'm not speaking. I don't know. Someone is trying to ask this, but her network is not clear. Can you try to put in the chat, maybe? Okay. When they ask you to generate the probability distribution function, they are basically asking for the PDF, which is the probability at x equal to small x. If you remember what we previously did, okay, at 1, it is 1 out of 9. At 2, we saw that it was 4 out of 9. Then at 3, it's 9 out of 9, which is 1. Usually the last value corresponds to 1. So when they ask you to generate these probabilities, the first part here is usually the same. So you get, to get the probability at x equal to 2, you'll get 4 out of 9 minus 1 out of 9. And we saw that it was a third. Okay. Then to get the probability at 3, you'll get 1 minus 4 out of 9, which gives you what? 5 out of 9?
5 out of 9.
So these are the probabilities they want you to generate, basically. Okay. And what is, okay. What is the other part asking us to do?
Find expectation of 2x minus 3.
2x minus 3. Does anyone remember how to use the properties? What will this one yield?
It would be 2 expectation of x minus the expectation of 3, which is the same as 3.
Okay. So we can use the property, but if you can't use the property, if you remember what I told you last time, you can generate a new variable for this expression. Okay. But I want to encourage everyone now to use the property. Okay. So what expectation do we get here? First of all, you need to get the expectation before you use it in the function. Okay. So expectation of x is 1 times its corresponding probability, then plus 2 times its corresponding probability, then times 3 plus its corresponding probability. Can someone tell me the answer here? Someone tell me the answer.
2.444.
Is it possible to give it in fraction? Yes?
22 out of 9.
2 and 4 out of 9.
22 out of 9. That's better since we are going to substitute it. Remember, it's not the final answer. So if it's not the final answer, it's always good to leave it in fraction form so that you reduce on recurring errors. Okay.
22 out.
Okay, put it here. Minus 3, which gives us what? This
17 out of 9.
Sorry?
17 out of 9.
17 out. Now this one, if you want, you can put it in decimal of, or you simplify it. Okay. So basically, this is what they expect you to do on that number. And they are going to set for you questions and they require you to use that knowledge of cumulative distribution function. Now, one thing I want you to note here is sometimes they're going to set a question and they will give you a function with a constant, a cumulative distribution function with a constant. Okay. So for example, if they told you that the function maybe was kx squared and your x is varied, I'm picking, let me use a word we've just used. So they will give you a function like this. And the first question they're asking is, what is the value of the constant? Okay. I know some of us are used to substituting in the values of x and then we keep adding. If you do that, you'll get it wrong because what they have given you is already accumulated. Okay. So what happens when you're given this, you pick the last value. What is the function? What does the function get to if you use the last value?
The function is 1.
The function is already supposed to be 1 if you substitute the last variable. Okay, so that is what I expect you to be using to generate the value of the constant. Okay, so you need to note that don't start generating variables. I've seen it before. People start substituting in, then you get 4K here, and then on the other part, you get 9K, okay? And then afterwards, you start adding like this, and then you equate 1. This will be wrong. If you do this, you end up getting a wrong answer, okay? So if they have told you that it's a cumulative distribution function, then expect that function to be equal to 1 if it's a discrete. If the variable you are dealing with is a discrete random variable. So substitute the last variable in the function and then equate to 1. That's how we do it. Okay. So I hope that's clear. Then the other thing I want to look at is I'm going to leave you to do number 4. Okay, I've told you to construct a cumulative distribution table for a discrete random variable. Number of heads when 3 fair coins are tossed. That one you'll do. Okay, and remember, if you toss 3 coins, each coin has each side has a chance of 1 out of 2 of appearing. So if there are 3 of them, they are independent. So I expect you to multiply, and you need to know how to do that. Okay. I want to look at the mode. The mode, if you remember from statistics, it is that number that appears the most. Okay, or with the highest frequency. Okay, so we shall be using that knowledge to work out numbers here. They are going to be asking you to find the most likely number. So what we do is we look at the table, the PDF table, and then we look for the value of x that gives us the highest probability. Okay, so that value which gives us the highest probability is usually our mode. Okay, so if, for example, we get a value of x, maybe let me say the highest probability is like 0.65 and it's corresponding to x equal to 3. So we shall say, since the highest probability is this, then mode is equal to 3. Or you just say mode is equal to 3 since it gives us the highest probability. And then they will ask you to look for the median. Okay, though the most common questions are usually around mode, but the median divides a given set of distribution into 2 equal parts. Now, you've looked at the cumulative distribution function. Now, they're telling you that for you to get the median, you're going to look at the table of cumulative distribution function, and then you look at that point when the function starts to be greater than 0.5. For example, let me go back to my whiteboard and I look at the examples we've done. If you look at these examples, let me see. Okay. If you look at, for example, this other example here. Let me see. Is 4 out of 9 greater than 0.5? Can someone check? If you got 4 out of 9, do we get a value greater than 0.5?
No.
It's less.
No,
so that one can't give us the median. Let me use the other one. I think it brings out the concept easier. Okay, if you look at the second example we did, we saw that 1 was corresponding to 0.13, then 2 was corresponding to 0.54. So you see that 54 is greater than 0.5, okay? So the value which gives us that probability usually becomes our median, And remember, with the discrete, we cannot get values in between, They're usually whole numbers. So we usually take that value that gives us a probability that is immediately after 0.5. And in this case, 2 is giving us 0.54. So automatically 2 becomes our median, okay? Because its cumulative distribution function, the value it's giving is beyond 0.5. I don't know if that makes some sense. Does it? Yes, no?
Yes.
Okay.
Yes.
Yeah, so you are going to meet questions that will ask you to use this information I've been trying to help you understand. Okay, I guess that's it for this topic. What follows trial questions that I gave you. I know some of you have tried them out. Those who are yet to try, please go and do these questions. Okay, they contain concepts that we've been discussing. These are 7 questions, and they should be able to, to stimulate your thinking along the concepts that we've just discussed. Especially number 5. Number 5, last time we looked at series, okay? So they have not given you where it's terminating from. That means it's a series to infinity. So you guys have done series. So I expect you to know the formula we use for sum to infinity. Okay, that is what I will expect you to use for that. Then this one, number 6, we did a similar question last time. So I will expect you to do it with ease. I guess the rest of the questions are direct. So you can go on and try out the questions. If there are questions that you're having, I can attend to them before we end. I see we have 5 minutes. Yes, Ananda.
Teacher, did you say that for median, in order for us to find it, we have to use the cumulative distribution function?
That's right. We use cumulative distribution function, and then mod, we use the PDF.
Okay, teacher, thank you.
You're welcome. Okay, girls, do you have more questions? So, John, if the girls are not having questions, can you tell them what we are going to start on? Because I want us to balance the board. We shouldn't do statistics only. Let's now cross to mechanics next week. So can you inform them what you are going to teach them, so that those who can read ahead, they start reading ahead and they come when they're well versed with the content?
Okay, thank you so much, Theod. Thank you so much. The girls, good morning and praise God.
Good morning. Good morning.
So I encourage you to have all these concepts on your fingertips for the probability. It doesn't mean that when we are going to start a different section that you should forget all these ones. It comes as a single paper. That is part 2. So I encourage you to keep all these concepts on your fingertips right from where we started. So we are going to start with the projectile motion. I sent the notes. The notes I tried as much, make them very simple and understandable, although I shall have to explain more. We shall have different, I didn't write examples. I wrote them in form of questions so that we go through them together in the lessons. So you have the notes in the Google Classroom. I sent them there. So feel free to go through them so that when I come, it eases my work. We may even start with the questions. Somebody would raise some questions that according to what I read, this is this. That's where we shall start from. That's it. You have the notes already. So our starting shall be very simple.
Have we looked at the notes? By the way, do you go to Google Classroom? Some of you wait for Zoom sessions only. Do we? Okay, I hope we don't have people who are just waiting for Zoom lessons. You should visit the Google Classroom because it has all that information.
Because we put the notes there. Yes.
Yeah. Let me try to visit.
Then I have realized a decline in attendance as I've been taking roll call. We've been 66 minus with 2. It means the girls have been 64. I don't know why today the number has been very low. So the girls, please let us know if you have a friend and she has shared with you the challenges she's going through. Let us know so that at least we can have a background of how to help some individuals.
Okay. Thank you, John.
Is it okay, girls?
Yeah, so,
Yes, teacher.
Yes, teacher.
Okay.
So for those who don't want to visit Google Classroom, Mr. Wakana has already posted the notes. They are there. You will go under classwork. I'm seeing promotion notes. So you click on that. Yeah, it's a PDF. It was assigned to 92 girls. So go there and download it. If you are having a computer, you can download it and put it on a computer so that it's easy to access. And if you're using a phone and you have space, you can as well do that. Okay. Try and go through it prior to our next meeting on Tuesday. Yes, John, do you have anything to add?
Yeah, there is this question which I think someone is asking it, and very many are asking it. That shows that they are not following up some of these things. I would request Teacher Theory to answer to these girls about posting the work that is being recorded.
About what?
Because about posting the work that is being recorded, as far as I know, that we post it on YouTube.
Okay.
I don't know, you can throw more light.
Yeah, this work is supposed to be hosted on YouTube, though at times we get overwhelmed by work and we forget. But I'm going to post today's session right away before I forget. I'm having an S1 class after this, but let me commit to post today's lesson. I keep forgetting, to be sincere. Yeah, but I have all the recordings, I think, on my computer. So I'm going to try and I upload them. Yeah.
Though the best solution would be the girls to attend. Please do attend.
Exactly. They should all be in class so that they ask whichever question. I know we all have different challenges, so we can't be at par, but let's try our level best to be in class so that we can interact with the teachers. Okay. Yeah, so I guess that's it for today until we meet next week on Tuesday. Yeah.